Welcome to PyCon 2023, or PyCon Ireland 2023. Thanks for coming to this talk. When I done the title for this talk a long time ago, it was rather hefty. It was called Leveraging AWS SageMaker for Scalable AI Deployment with Python, a Real-World Journey. To save my fingers, I just put Python and SageMaker on here. Also, this is my first talk since the before times. I think the last time I talked was back in February 2019, so I'm almost 4 years rusty. So please be kind, because I'm pretty rusty. The obligatory About Me section, it's not very interesting, but has to be done. My name is Stephen McCullough. Swim, if you know me in real life, or SWM, just depending on what floats your boat. SWMCC on most of the interwebs, and I'm currently a cloud architect for a company called EXL. EXL is a global analytics and digital solutions company serving various markets, basically insurance, healthcare, banking, financial, etc. Not surprised if no one's heard of us, but we have currently just opened up our international headquarters here in Dublin last month, so hopefully you'll start hearing more about us as time moves on. You can hear from my accent, I'm based in Belfast. EXL is primarily an AWS house. As they're starting to move in, which is good to see, Python is their language of choice. Myself, I also have a love for Python. I've got a soft spot for Ruby and Elixir. And I currently organise the Belfast Ruby and Belfast Leader Elixir meetups. And I was a former organiser of the PyBelfast one, but I've handed that off to a fellow called Kyle, who is doing a way better job than I ever did. And if you are interested, you shouldn't be, you can get stuff on swm.cc or links.swm.cc, even though I'm thinking pretty much all the links in that old site now go to dead links, but sure. When I do a talk, I like to outline where it's going, what's going to happen, and when it's going to happen. So here's the outline that I will talk on for the next while and bore you for the next 25-30 minutes. Intro to AWS SageMaker. What is it? Just in case you didn't know, because I didn't. Python and SageMaker synergy. A real world case study that we had done on EXL. Best practices and pitfalls. I think this is our 4th deployment of using SageMaker with Python, so we're pretty good at cleaning up after ourselves and admitting when we've done things wrong. Then there'll be a tiny bit on the future of AI with Python and SageMaker, and then that'll be it. If there's any questions, I'd prefer if you came up just afterwards and talk to me. I'm not a packet of peanuts, so you'll be able to see me. So come up and I'll answer any questions that I can. So first off, what is AWS SageMaker? Well, SageMaker is a cloud-based service provided by Amazon that enables developers and data scientists to build, train, and deploy machine learning models at scale. It basically simplifies the process of machine learning with tools for every step of the model lifecycle. I'm not a data scientist by any stretch of the imagination. I'm a developer that has found himself in the unfortunate position of being a cloud architect by circumstance. I'm a code monkey at my heart, so I'm definitely not a data scientist. Some of the things were way above my pay grade and my brain. Despite its many advantages, it does have drawbacks, so I've tried to give 3 advantages and 3 disadvantages of it. Basically, it's seamless integration with the AWS ecosystem, which you could see as a con, but for fast iteration, it allows you to scale quickly. It allows you to use anything inside the AWS ecosystem, so it's fast to market. The thing that I didn't like, the learning curve, you have to have a familiarity with the AWS services to really make it work properly. But the feedback, it was just, hang on, I'm talking about advantages, I told you it was rusty. Fast development, feedback and turnaround, quick to market, and it's fully managed, so you don't have to bother with DevOps or anything like that there. You just put it up, and if you do things right, it'll just manage itself for the most part. The disadvantages are the cost considerations. I've always worked for small and medium-based companies, size companies. This is my first time in the enterprise, so the cost considerations don't really reflect to us in EXL and the clients that we would use, but it's definitely something that, if it was a startup, would I be using it? I'm not 100% too sure, because I did see some of the costs spiral. The complexity and the learning curve. While you can use their pre-built algorithms and certain things, and that would help someone like me that doesn't come from a data scientist background to get you moving very quickly, the learning curve does get up. That's probably more my thickness than anything else, but I did think that the learning curve was quite steep. And actual data scientists that I talked to said that while it is flexible and you can extend it, it does seem to have certain limited customization that some data scientists really wanted. But there's no glove that fits everything. And also the vendor lock-in, you could also probably see that that's also pretty much a disadvantage if you see that being locked into AWS is going to be a disadvantage to your system. So the key features of AWS SageMaker, or SageMaker as I'm going to call it now, it seamlessly integrates with Jupyter notebooks. I don't particularly like them myself, I'm coming around to them, but they seem to have integrated into very nice. That allows you to basically start from scratch and prototype up very, very fast. As I say, it has built-in algorithms. That speeds up the model training process, which definitely is a big win. Model training. Again, I said the model training is a big thing, and I'll be talking about that more in a bit, but it's definitely something that I found it was almost very easy to get used to for something that's very important to it. Hyperparameter tuning. Basically, that automatically tunes your model for the best performance. So you put in these parameters for the learning process. So first, like, say if you wanted to put in a decision tree, you would put in what the max depth is, what the minimum sample split is, max features, certain things like that there. That was a really nice thing. You've seen very fast feedback in your models if you were to keep on tuning your parameters. The deployment options, which I'll talk more about. Basically, the deployment options for SageMaker are excellent, and if you use them correctly, saves you an awful lot of time, especially when you put it up in production. And monitoring and logging, probably outside the scope of SageMaker, but it really is something that you need it. It is easy to do, but it's only easy to put it into CloudWatch and CloudTrail. If you didn't use them, it would probably be particularly, I wouldn't say it wouldn't be the easiest. Streamline workflow. That basically means that you can take your thing from ideation straight to deployment. The dev cycle is so much faster. I've had nightmares about saying that word, interoperability. Basically, it works well with everything else in the AWS ecosystem. And resource optimization. So you've got advanced functionalities to manage resources effectively. Again, the hyperparameter options. So for the sake of one of the things that we used with case studies was financial services. So that was for credit risk. So those models are quite complex depending on what you're doing, especially if it's a business instead of a person, and you would have a lot of data. Basically, manually tuning these models would be a costly time in both resources and time. So that, depending on what organisation you are, that could be a killer. And it was definitely a fast process for us once we got used to that. And auto model tuning inside there, that's what I was talking about the model tuning for credit risk. And cost-effective uses. So, that really saved us a lot of time and effort. And scalability and efficiency, being able to scale horizontally or vertically depending on your use case with minimal configuration was a real goal winner for us. So why SageMaker for AI and ML? Well, again, as I said, it was an end-to-end platform. This gives reduced time to market. Cost effectiveness comes time and time with that. Collaboration, it facilitates a lot of teamwork. For our cases, we had teams in India, Belfast and Arizona. We worked fine with everything within SageMaker. It wasn't a one person or I think there was 20 people working on our models at one time. Flexibility, as I said, it's very flexible. It's got built-in features. It allows you to use your own algorithms and frameworks. If you want to step a bit further, you can build your own models. So we built our own natural language models to use for a certain application. The automated workflow, so that's the model tuning again. Security and compliance, again, high security standards and AWS, so giving your IAM rules minimal as much as they can. That's perfect. Again, it's probably outside the scope of SageMaker. It's wide ecosystem compatibility, because when we were offering our stuff, we offered it with step functions and event sourcing, SKS, SNSQs. It really fitted in well to our paradigm of working. And again, rich monitoring and analytics. Again, probably outside the scope of SageMaker, but once you combine this here with CloudTrail and CloudWatch, and you have to monitor your models very closely. It's a fantastic way to be. Accessibility as well. It's just out of everything I've tried, it was the nicest one that we have came with. What's the role of Python with it? Well, we're in a Python conference, and I love Python. I love the fact that it's versatile. I love the fact that it comes from everything from web until basically it's not like Ruby or Elixir or even JavaScript, where it's one particular facet of the development. It hits everything. So I found this slide. Python is broadly known as the king of languages when it comes to AI and ML. Now, I might be biased, we might well be biased here, but I'm very, sceptical of these stats, but I don't think it's too far off where we are. It is a very good one. People I've been talking to are using Rust more, but I don't know why that's just who I'm talking to, but definitely Python seems to be the top of the tree for that. So why did we use it? Well, we all know Python's got a rich ecosystem. There's no point in going on about it. We've all used it here. The community support is fantastic. So you put the community support, if you're starting off from scratch with a team, along with the rich ecosystem for AI. So you've got TensorFlow, PyTorch, Pandas for data manipulation, NumPy for data manipulation. It's just a very clear winner. Ease of use, the Python's clean syntax. There's nothing as nice as, and this is the code monkey in me again, clean syntax for Python. Python code is beautiful. Again, there's that word I can't pronounce, interoperability. Awful. Basically, it will integrate with other languages like C and Java. It's very, very versatile. It's platform agnostic. The team in India was using Windows laptops. The one in Arizona was a mix of Mac and Windows, and we were on Mac. If you were using Ruby or even Node, it would be a pain to keep them going, but it was seamless with Python. You've got maths libraries, like again NumPy, SciPy. You got visual tools like Matplotlib and Seaborn to be able to visualize what you're seeing. The natural language processing is fantastic in Python with NLTK, I think that's what they call it. And research and academic places, they're very tightly coupled to Python, and that ensures that we've got ensuring that we've got the latest techniques and latest patterns readily available. We don't have to wait as long as certain other languages for them to come down the pipe. And it allows for rapid development, and that's basically what everything comes down to, is getting everything out as quickly, as seamlessly, and as nice as possible. And basically simple code again, and that goes in with the code monkey in me. I like seeing simple code. So Python and SageMaker synergy. Python really complements SageMaker really, really well. This is down basically to an SDK. The SDK support easily integrates and allows you to manipulate machine models. It's straightforward to build, train, and deploy. Again, Jupyter Notebooks built in. It's a first-class citizen. Data preparation, so you've got pandas to data manipulate. Anything come across for sanity for your training. And again, flexible training comes into that. Real-time analytics. Services deployment. It allowed a lot for services deployment. That's something that we leveraged very much in EXL. Everything that we do on this particular app that we use for this year is all serverless, and we use the SDK primarily for everything from the very start of the foundation, from ideas to deployment to monitoring. You can use batch transform depending on what you want to do. And again, this is probably a cheap one, API integration. You can basically go through the third-party apps or AWS services to talk to the machine learner, the machine endpoints. But you could do that in really anything, but it's just fantastic the way you could basically use Python from the very start to the very end within the application. And basically the ease of automation, automating deploy scripts, automating the way the hyperparameters were called, certain things like that there, just using Python and the SDK made it a real joy to use. So the basics of writing Python scripts on SageMaker, basically you've got the model life cycle, and the model life cycle comes in several portions. You've got the data preparation, you've got the model definition, you've got the model training, and you've got the model deployment and endpoint creation, and then you have inference. Hope I'm pronouncing that right. So that's basically the overview of the model life cycle within AWS SageMaker. So this is data prep. So the objective of that is to basically prepare and pre-process data for model training. So you can use certain tools like Python libraries like pandas and NumPy for data manipulation. The process is clean the data, handle missing values, remove the duplicates, basic sanity checking, because the data that you're getting in necessarily won't be clean, and you have to clean it up every time or else your models just become useless. You can also encode category variables. You can split your data into different types of groups for your training data, your validation, your test cases. And AWS integration, basically you store your process data in S3 buckets. You probably could store it outside of that, but I found it is probably the best way is to do it for S3 buckets every single time. And SageMaker processing, so you process basically after all this here, after the data is prepped, then you process it. And here is a simple script. It's a bit trivial, but it shows a good case of what you can do. Basically, this demonstrates the data prep stage. It's using pandas and NumPy libraries, if I remember right. And it includes steps for data preparation, transformation, and uploading the process data to an S3 bucket for use with SageMaker. So you basically set up your session in SageMaker. You define your role, you give it the S3 bucket details of where the data is going to be, you load the data set. We use pandas in this example. Then we basically perform the necessary pre-processing steps. That's handling missing values, normalizing the data, certain sanity things, like I said before. And then if you need to, I don't know this one here example, we convert the pandas data frame to a NumPy and then back to a data frame. And then we basically save it, and then we upload it into S3. And then we can go on to the second part, which is model definition. Excuse me. We define, the objective of this here is to define the machine learning model and its architecture. And you can use Tensor, PyTorch, or XGBoost. The examples that I've given here are XGBoost. The process is you select the appropriate algorithms or framework. You define the model architecture, that's layers or activation functions. You configure the hyperparameters. I know I'm going on about hyperparameters a fair bit, but you configure them, and then you integrate it into SageMaker, and then you basically can use the built-in algorithms or use your own model. And here is a script that demonstrates that model definition stage. It's using XGBoost, which is extreme gradient boosting. It's basically a fancy decision tree. It configures the training job parameters. So with everything else that you're doing when you're using the SDK, you have to set up the session and the role and the data paths, and that's what we're doing up there. Then you retrieve the container image, the URI from the current AWS region. Then you use what's known as an estimator definition. You define the estimator with necessary configs like instant types. It's beyond the scope of this talk, but you can put it into an estimator, but it's very comprehensive. And you put in the hyperparameters, and that's the parameters that you want for your model, for the XGBoost boost model. Then you put in the input for the data configuration is, and you specify the input data, and you format it, and you give it the source paths. And that's basically your model defined. Then you have to train your model, and this is where the money is. Basically, you have to train the model using prepared data set. There's no nice way around this here. You have to have your client give you a particular data set. The data set that they give you, they will have to be obviously manipulated or changed. It's very rarely that you can get a data set that's just nice. You have to set a SageMaker estimator with the model and training parameters. Again, it changes case by case. You specify the S3 pass for training and validation data. Again, then you choose the instance type and the number for the training. And then you execute it. You call the fit method on it, and it basically starts the training. That's it. There's no real magic behind it. And again, the training jobs are managed and scaled automatically by SageMaker. A bit of a simplistic version, but you do your installation, get your data paths, get the model container, define your estimator, put in the hyperparameters again, input the data config, and then you start your training. Depending on how you want to do it, you can get very sophisticated. We got pretty sophisticated in one of the use cases that we used. That's me basically saying this is like a very trivial examples, but to give you, it gives you a very potent way of being able to use Python, the SDK, to get as much as you can out of SageMaker. Then you have to evaluate your models. This is where it sort of got above me, and this is where the data scientist comes in. Basically, you have to evaluate the trained model's performance against predefined data. You get metrics, so you have to measure certain things like precision and recall. That gives you the F1 score. The F1 score is some sort of mean between the precision and the recall scores. I know it's between 0 and 1, and the higher, the better your models is. I think that's how it works. I can't remember. Again, I'm not a data scientist. You basically use the test data set to evaluate the model performance. The more stringent you are in this process, the better you are. And this is key to having a successful deployment of AI or machine learning. You utilise SageMaker's processing. You can either do it locally, or you can for evaluation, or you can use SageMaker on the cloud. We use SageMaker basically on the cloud all the time for this here, just the sheer computing power that it would need. You have to analyse your model predictions versus actual outcomes. You do that basically through this particular script that I'm given. Basically, you see, you do the usual, you initialize, you define the pass, you download the model, and you test the data from S3. Well, you could probably do it from somewhere else, but S3 seems to be the best place. Extract and load the model, load the test data, make the predictions, depending, again, it varies case to case. Then you evaluate the model, calculate the metrics, like accuracy, F1 score, and generate a classification report. Depending on that classification report, then you can go ahead and reevaluate your methods or your models. And that's when you get for inference. I hope I'm pronouncing that right. Use the trained model to make predictions. Basically, you can use batch transformation for large-scale asynchronous predictions. We use that for one of our use cases. And that's basically if you, say, have a financial institution and you're wanting to do credit risk against a customer. Doing it against a person's fair enough. But if it's a business, they also come with a lot of credit references and you maybe do 50 or 60 at one time, and that's when you would basically use batch transformation. You can have real-time inference as well, so we used a mixture of both. The good thing is you can have a mixture of both depending on your use case. The process is you deploy the model to an endpoint, and then you basically just pass it in the payload, and then you get the result. And you got to prepare the input data, and you got to serialize for model consumption. and then you invoke the endpoint to get predictions. So this is the version that I have put down. Basically, you initialize a SageMaker runtime client to interact with the deployed endpoint, and then you specify where the endpoint exists, and then you prep your sample data, serialize it, get the prediction request, and then deserialize it and see what the prediction was. And that's how you basically use SageMaker in a basic fashion. I did talk about deploying the endpoint. This is basically it. I don't know why I put it after this particular slide, but there you go. Basically, it's making the model available for inference, whether it be batch or whether it be for real time. You use the deploy method on the SageMaker estimator. You specify the instance type and the number for the endpoint. The features are auto-scaling, so you can put in auto-scaling. This is where everything comes in. You can get a quite potent, nice feature set from that there. You can use A/B testing, so you can test differences between models simultaneously. Once your models start to mature, this is a fantastic way to be able to see if things are working in your way or not. It's a really handy tool that you can do that there. And again, it's very easy to do. There's hardly any configuration that needs done for it. And again, that's why I put the life cycle in. It's deployed after the model training and evaluation. So it'll only get deployed to production and be used for inference when you're happy with what happens. So that's that constant build pipeline that you can put in automatically. And I keep on probably harping on about this a bit much, but basically you have to have continuous monitoring and logging with CloudWatch to be able to see what you're doing, how's it going, and it's just a fantastic thing to do. And this is the deployment script. It's a very trivial one. Again, you do the initialization, you model the artifacts, that's defined in the S3 pass, where the artifacts are stored. You use the model container, XGBoost container in this case, for this particular AWS region. Then you create a SageMaker model object. Then you deploy to the model with the deploy method, and it gives you back magically where the S3 endpoint is. Again, you can make this as comprehensive as you want. This is a very simple one, but you can see what you can do with very little code. Once you get into it, you can give yourself a really, really good potent solution. And it's nice when you get that going on a particular system. I said I'd give you a case study. It's not as much detail as I wanted because the EXL lawyers found out that I was doing this talk, and there was an NDA. But come up to me afterwards, and I'll talk to you more about it if you want. I didn't say that. I forgot this was being taped. Right. Well, nice knowing you. Basically, we had a banking consortium in a particular country, and they had two challenges. Basically, they had to adhere to strict regularity compliance because they were amalgamating several banks, and it got them even more stringent. And basically, because they were coming together, their data quadrupled within the space of this merger. So their traditional methods were inadequate to deal with the amount of stuff that was coming through. So they had limited scalability, they had an ability to adapt to evolving regulatory requirements because of just politics, I suppose. They needed an efficient solution, and they were capable of handling, it had to be capable of handling vast amounts of data. And big thing was insurance compliance and banking regulations. They were very slow to adopt banking regulations in this one here, and it was starting to really worry them. So they needed a solution that could deal with this, and the objective was find a solution that combines efficiency and data processing with strict adherence to regularity standards. So leveraging the SageMaker for compliance and scalability. So we decided to address these challenges. We adopted SageMaker, utilising the managing platform to streamline the deployment of machine learning models at scale. We used Python for its robust libraries and community support, and it was our primary programming language. We had others in it, but Python was the main one. This gave us a potent combination and allowed us to develop and deploy the models swiftly. We ensured scalability, security and compliance, and we heavily used the built-in features for SageMaker, like model monitoring and data encryption. So that's just basically me just going over everything. The writing is too small in my laptop to be able to see what I'm saying there. Yeah, and we basically used real-time inference and batch as well, because it was just a handy thing to do when we could move into certain arenas as quickly as possible for real-time inference. And this is frozen on me for some reason, which is good. So I think in the last slide I said about one-click deploys. The one-click deploys really hurt us in case when we were starting off. So without minimal configuration, we could use blue-green deployments and do the A/B testing. That's when that came in, and that was a minimal configuration. Basically, we used CloudWatch, and we basically put performance monitoring and alerts. And we used the dashboard for basic builds, and it gave us a good bit. So basically, we utilised the SageMaker instance with Python, and basically it came up with 40% increased in processing efficiency. So that was quite good. Robust logging and monitoring. It was no part down to SageMaker and Python. Best practices and pitfalls. Again, I'll go over this as quickly as I can. Code structuring. Basically, you modularize your code. We're all Python developers. We know about that. Using SageMaker libraries. The data management. Using Data Wrangler to clean and prepare the data, to visualize the data. You basically have to use your S3 bucket organization. Make sure you've got good naming conventions. Data pre-processing. Again, I just said it there. Data Wrangler to clean it, prepare and prepare your data. For model training, hyperparameter tuning is key. Put in distributed training if you can. And again, best practices. Using batch inference and endpoint monitoring, security. Using IAM-based rules, data encryption for data at rest and for transferring. Again, probably outside the case of AWS or for SageMaker. Using the right size instances. Cleaning up your resources. Common pitfalls and solutions. Overfitting models. That's basically when your models have gotten excessively complex. Negatively impact performance. So that's basically your models are too specific. You need to be able to use regularization, pruning your decision trees, simpler models, increasing the size of the data set. You really need to prevent overfitting, or else your models then become really bad. You can use data leakage, so that's basically when you segment data before you're training. So that's when I talked about having different types of your data when you're using Python. Yep. So I think that's me. I'm sorry it's went on too long.
Thank you.